Hello and welcome everybody. My name is Stefan Schmidt. I'm a principal architect at the Open Source Technology Center at Huawei. Today I want to talk to you about an IoT Gateway Blueprint we have been working on in the Oniro project for the last couple of months. Throughout the videos we want to show you some of the main features of the Gateway Blueprint in its current iteration. That would be running as a Wi-Fi access point to allow you to connect all kinds of Wi-Fi clients to your network. That could be your laptop, your mobile phone, or some other IoT gadget, as well as running as an OpenThread border router to allow you to connect all kinds of thread and OpenThread devices to your home network. Let's have a look at the hardware setup. As you can see, we are running with off-the-shelf hardware here. On the left side, you can see in a Raspberry Pi 4, connected to the Raspberry Pi 4, there's an USB dongle featuring a Nordic chipset that allows it to act as a thread radio, in total allowing the Raspberry Pi 4 to act as an OpenThread border router. On the right side, you can see an Arduino Nano 33BLE, which is running the Sapphire operating system and is configured in a way that can act as a mesh node on the OpenThread network. On the bottom you can see a QR code which will be later on used together with the mobile phone to onboard the Arduino board to the OpenThread network. Let's have a look at the shell of the gateway and see what kind of services we are running and what kind of configuration we did to make it all work. You can now see two shells on the screen. On the left side is a shell on the Raspberry Pi 4, our gateway based on Linux. And on the right side you can see a shell on the Arduino Nano, our mesh node, based on Sapphire. Both of these systems have been built with the Oniro project, which uses an Yocto-based build system to build images for Linux as well as Sapphire. For now, we want to focus on the gateway side. We want to explore the system, see what kind of services are running, how they are configured, and how this all comes together to provide us with a Wi-Fi access point as well as an OpenThread border router. If you look at the processes currently running, there are two processes that are really interesting for us. One process is the OTBR agent, which is the core of the OpenThread border router, and the other one is Network Manager, which is a common network manager tool on the Linux distributions. We use it for all kinds of networking services, including the Wi-Fi access point functionality. Let's start with that. We pre-install one file to pre-configure the Wi-Fi access point feature on the images for the gateway. This is using a feature on Network Manager called Hotspot, which allows us to provide the Wi-Fi access point feature and just configure some specific details. So what we do here is we make sure it runs on the right Wi-Fi interface. We have some specific Wi-Fi settings, the band, the channel, and so on, and also setting the SSID for the Wi-Fi access point. Even more, we have Wi-Fi security settings, being the pre-shared key, for example, shared here. As well, we are offering a way to set the IP address for the device. And this is the only file needed to make sure that the Wi-Fi access point comes up by default. We will see it in use later on when we use the phone to connect to the Wi-Fi network and onboard the thread node. Switching over to the OpenThread border router, we have one configuration file that we are using to bring up the system. It uses the OTCTL command, which is a shell, which gives us a shell on the border router itself. So what we basically do is we start and stopping the thread service, we are bringing the interface down and clearing the dataset. Then we start afresh. We're initializing a new dataset, setting some basic network settings for the thread network that can be the PAN ID, the extended PAN ID, as well as the network name and channel. One thing I want to pay a bit more attention here to is that there are two different ways of credentials. So one is the commissioner credential, which allows the commissioner, in our case an Android app on the phone, to join the network and onboard new devices. This has a specific credential which we use in the Android app later on. There's another credential, the joiner credential, which would be something that is encoded in the firmware of the device and encoded as well as in the QR code, which we use for onboard this device later on. Once we have set up everything here, we commit the dataset and bring up the interface and start the thread service. If you look at the current state of the OpenThread border router, we can see that it's completely disabled. If you now run our configuration script, the state changes to be a leader. A leader in OpenThread terms means that it is running the whole OpenThread network. We can also see that it has various IPv6 addresses assigned, which we can also see with the normal Linux utilities. If you look at the WPN interface, you can see that all the same IP addresses are shown here. With that, we can switch over to the Arduino side and see how we can configure the system there. Let's switch our attention to the right side of the screen. Our mesh node, which is running on Zephyr. To start with a clean slate, we are going to reboot the system. During reboot, we see all kinds of log messages passing by. One of the log messages we are seeing is join failed. That comes from the fact that the firmware is configured in a way to join an existing thread network while booting. This is not possible at the moment, and I explain why later on. As on the Linux side, we have an OT command here, which we can use to look at something like the state of the OpenThread subsystem, which is disabled here again. We can also look at the IP addresses, and we can see that one IP address is assigned to the interface. If we now go ahead and ping this IP address, this is obviously working because it's a local interface. If we now try, on the other hand, try to ping the IP address of the gateway, the ping is timing out, which is also expected. The next thing we are doing here is to find the actual OpenThread network to see if it's available. There's a scan command, which allows us to scan the bandwidth for the OpenThread network. And it finds our network, which is the Oniro thread with the given extended PAN address and so on. One detail we need to pay a bit more attention to here is the 0 up front. This 0 indicates that the thread network is not currently accepting any joiners to join the network. This is something that will only be enabled when an external commissioner asks the network to do so. In our case, we are using the Thread Android application to onboard our Arduino to the OpenThread border router. So let's switch over to Android and show what's going on there. We are now at the stage where we can use the Android Thread application to onboard the device to the OpenThread network. To do that, we need to ensure that the mobile phone is actually connected to the Wi-Fi network spun up by the gateway. So that is something you can see here. The Oniro project Wi-Fi is being announced as a Wi-Fi access point, as we are configured it before with Network Manager. You can simply join the network the usual way and getting an IP address provided via DHCP and DNS and have full internet connectivity. Once that is done, we can start the Thread application to actually look for border routers. You can see two border routers listed here. It is actually one border router with two different IP addresses, one IP version 4 and one IP version 6. If the border router is discovered over MDNS, we can try to join one border router here, which is asking us for the password. In our case, that is the commissioner credential I mentioned before. That allows the commissioner to actually enter the network and onboard new devices to the network. After entering the password, we can see that we join the network as a commissioner, and at that point we are able to onboard new devices to the network. There are two possible ways to do that. One is using a QR code, scanning it with a camera, or by entering the join password manually. The join passphrase itself consists of two different pieces. One is the joiner credential I mentioned before, which is hard-coded in the firmware, but as well could be used manually in the passphrase or in the QR code. And the second part is the extended MAC address of the device, which is also obviously part of the device and can also be encoded in the QR code or entered in the manual password. In our case, we are using the QR code to demonstrate the onboarding. At that point, the commissioner is sending out the information to the border router. The border router opens up to actually allow joining of new devices. So that is the 0 we have been seeing before. It now switches over to joining mode. And at that point, the device is actually able to join the network and being commissioned and onboarded correctly by the external commissioner. This process can take a moment. And in the end, we will see that our product has been successfully onboarded to the OpenStrat border router. Let's switch over again to the shell and see what we can do now. Following this successful onboarding with the external commissioner, we can now see that our Arduino node is fully onboarded onto the OpenStrat network. You can see the join success message here. You can also see that the current role is role number 2, which is a child. So basically it's a child or leaf node in the OpenStrat mesh network. Later on during the demo, we will most likely see the device stepping up to be a full router, so being able to route packages for other parts of the network as well. We also can see that the device has now more assigned IP version 6 addresses, and we just saw a current role change. That means the device is now actually a router in the network. Being part of the network also means, obviously, that we are now able to ping the IP address of the gateway network, something that we haven't been able to. So that means that the device is fully onboarded into the OpenStrat network and network connectivity is possible. So let's wrap up what we have been seeing in this demonstration so far. We are demonstrating the IoT Gateway Blueprint of the Oniro project with two main features. That is a Wi-Fi access point to onboard all kinds of Wi-Fi clients to your network, as well as an OpenStrat border router to onboard all kinds of Thread or OpenStrat devices to your network. For the future, we are planning on a few enhancements to this blueprint. One would be to integrate the Meta project, formerly known as CHIP, Connected Home over IP, to have as an application layer protocol for all kinds of devices. Another thing we are working on is having a fully automated over-the-air update system, which allows you to do updates for the gateway itself, but also assisted updates for the smaller nodes on the network. Thanks and goodbye.